All right, now let's add a folder named Service Extensions under our extensions folder. We'll say it's Service Extensions. All our extensions, the common extensions would come in here. Let's create our first service extensions and let's name it as CorsServiceExtensions. All right. Let's make it public static, and let's add a method, and let's name it add custom course. Add custom course. This is going to return our service collection. We can have a string array of policies. For each microservice, they can have a single or multiple policies. Return those services. Let's use the service.addCourse. Let's define our options. And we are going to loop through all the policies. All right, let's add a policy. Let's say policy name and policy. Let's add those policy. For now, we have two policy definitions. One for the gateway only policy, and the other is the public API policy. Let's name it as policy name. And let's add a switch statement to handle different policy name cases. So let's define our first case. That's going to be the gateway only policy. Add our gateway only policy. And let's define our Now let's add our public only policy case, public API policy. And maybe let's just set the default case to throw an exception. Let's add our default case and maybe say it to throw an exception. It's going to be an invalid operation exception. Invalid operation exception, and let's say it to something like unknown policy and pass our policy name. All right, with that done, let's move on. Now let's go back to our weather service and let's just clean it up. Let's first close it all. And let's go back to our weather service. Let's add a folder named configuration. And let's create a class named register services, service registration class. In this class will be used to register all our services for the weather microservice. All right, let's add a method and let's name it as register services. In this method, we will register all weather services and we will call it in our program.cs file, making that file look much more cleaner. All right, let's return those service collection. Let's define our custom core policy, add cores, add custom cores. Let's add the project reference. So here we have it. Now let's pass the configuration and let's say we need the gateway only policy. All right. Let's go back to our program.cs file. Let's copy these services and let's add them in here as well. All right, let's fix these issues. Okay, we need the small s. Let's fix this. All right. Let's call our register services class in our program.cs file. All right. Let's add our services.register service class. Let's pass the configuration to it. All right. This looks so much cleaner now. Let's add our app settings configurator here in program.cs as well. We need the app settings configuration. Let's pass our base path and the environment name to it. Environment to the environment name. Let's close these parentheses. All right. With that done, our service registration look much more cleaner. Now let's add a middleware configuration file. Or maybe rather, let's just rename it to middleware registration. Let's add a method. Let's name it register middleware pipeline. This will return the iApplication builder. Let's add our use course pipeline to it. And we'll define the gateway only policy. All right, let's also add our middleware to restrict access. Let's do that. Now let's head back to our program.cs file and clean up the changes as well. So we don't need the authorization. We don't need the HTTPS redirection. All right. Now let's add our register middleware pipeline method. So we are only returning the iApplication builder services from our middleware. So that's why we cannot just put all in there, just only the application builders. But this looks much more cleaner now. Our program.cs file is more modular and more clean. We are following the same practices as we did in our API gateway. And with that done, let's move on. All right, now let's just test our application. Let's set up all the breakpoints and let's run it. Let's also add the breakpoint in our API gateway, request transformation. Let's call a breakpoint in here. All right, let's run it. Let's test with our weather service first. See, our API gateway and our weather service is up. Let's just first test with the microservice directly first. We must see an error. So you see, direct API gateway, the referrer is null, and this would throw an exception. It doesn't look very appealing though, but we will fix that too. Now let's just call it via our API gateway. All right, so it came here. It will add a referrer header. So we see that the referrer is received, and this time this will work fine. Oops, we forgot to return an early return. All right, let's just stop it and fix it. We need to return from here. Let's start again and let's just test it again. All right, let's just execute it. Let's also put a breakpoint. Maybe let's just also put a breakpoint on the response type, or maybe we just did the wrong thing. We forget to add the response transformation, and instead we added the request transformation. This will work fine, but we will see that the header was added from the request and it didn't execute it when the response was returned. All right, let's just fix that too. So this must say add response transform. And now this will execute before returning the response to the client. All right, let's first go to our launch settings and turn off the launch browser property to avoid opening the browser. All right, now let's try again. Let's open our Postman and let's hit that endpoint. All right, so we now see our breakpoints are hitting. All right, now this looks work fine. We observed that the response transformation is working as expected now, with the added headers being included correctly now. All right, let's test the weather service directly and confirm that everything is functioning. All right, this looks fine. The error response aren't very appealing, so let's just try to improve it now. Let's add a custom exception handler. For that, let's just go to our shared and common folder, common project maybe, and let's add a folder named exceptions. Let's name it as exceptions. Let's add another folder let's name it as handler. So this is going to be the exception handler folder. And let's add a new class and let's name it as custom exception handler. So this class will be designed to catch different exceptions, log the error details, and return a well-structured, user-friendly error response. All right, let's start building code for it. Let's define our logger. Let's implement the iException handler interface. All right, let's implement it. Now here in this class, we will define the exception type based on our errors. Let's first log the error. Let's say something like error message. Let's also add the time of occurrence. We will be using the UTC date time now. Datetime.utc now. All right. Now we will be returning the details of this error. Let's add the title, status code. Let's say it as details. And let's add an exception switch. So let's add a switch statement for our exception types. So we can add our first exception type as unauthorized access exception. Let's define its properties. We need the exception message as detail. And let's say access denied as our title. Let's add the status code as 403 forbidden. This looks good. Let's add other types of exceptions. Let's say validation exception. We will be using it in the future. So let's just configure it for now. Let's define the exception.message, title, and status code for this one now. Let's use as let's also define the status codes to be returned in our request. So that is 404 not found, or 404 bad let's say 400 bad requests, sorry. Let's also add our default case. Let's define the exception, title, and status code for this as well. Let's say it to internal server error maybe. This is going to be our default case. We can add more cases in future as per our need, but let's just lay down the foundation. All right. So let's define our problem details. This will be imported from ASP.NET Core MVC. So say our details as detail. So it's not popping up, we have to write it manually. Let's also define our instance from our context maybe. Let's define our request path. All right. Maybe let's add some extensions to it as well. Let's say a trace ID. So let's say problem details dot extensions dot add. Let's add a trace ID. Let's add the validations exception as well. All right, let's just check if the exception is of type validation exceptions, then add those validations error as well. Let's say them validation errors or validation exception. Let's add those errors. We are not seeing it here. Maybe we reference the long library. We need the fluent validation exceptions. Yeah, maybe we just reference the long library. Let's just fix this now. Yeah, so we referenced the data annotations. We don't need that. We need the fluent validations. This will fix it now. Let's see, now we see it. Let's write as JSON response. And let's return true. All right, with that configured, we are ready to give it a test. Now let's just start it. Let's just test it now. Oops, maybe not. Maybe we just forget to add that in our pipeline. So let's just fix that first. Let's go back to our weather service. So in order to consume it, we need to register those services and add them into our middleware registration pipeline as well. So let's do that. Custom exception handler. Let's add our custom exception handler. All right, let's try that again. And there you have it. This time you see it looks much more cleaner and more appropriate. All right, so you might be wondering about the potential single point of failure we have introduced by routing all requests through the API gateway. If the gateway fails, it could bring down access to all our microservices, which seems to contradict the advantages of a microservice architecture over a monolithic approach. If you are thinking this, you are on the right track. I had the same question when I started working with microservices and API gateways. And it's an important consideration, but don't worry, I won't leave you hanging up there. While it's true that the API gateway centralizes access, we can mitigate this single point of failure through several strategies. Let's discuss a few of them. We can create replicas with Kubernetes. By creating multiple replicas of our API gateway using Kubernetes, we can ensure high availability. If one gateway instance fails, other can take over seamlessly. Backend for frontend. For different clients like mobile, web, or TV, we can use separate gateways tailored to their specific need. Cloud multi-region deployment. Deploying our services across multiple cloud regions ensures that if one region goes down, others can keep our services running. Multi-availability zones. Within the same region, we can use multiple availability zones to enhance resilience. Or we can use those deployment techniques such as blue-green deployment or front door deployment. This can help us roll out updates without downtime, reducing the risk of introducing bugs. We will explore some of these techniques in details in the phase 3 of this course. All right, let's do a quick recap. In this video, we added a service extensions folder and created a CorsServiceExtensions class to define custom course policies. Then, we cleaned up the weather service by adding a configuration folder. We added a ServiceRegistration class to register services, moving these registrations out of program.cs file. Then we added a custom course policies and called the register services method in program.cs file to simplify the file. Then we created an app settings configurator in program.cs, added a middleware registration class, tested the application by setting breakpoints and running the weather service directly through the API and through the API gateway. Then we added a custom exception handler class to handle exceptions, log errors, and return the structured error response. Then we discussed the strategies to mitigate the single point of failure risk posed by the API gateway, such as using Kubernetes, BFF, multi-region deployment, and advanced deployment techniques. Alright, if you find this video helpful, please comment, like, share, and subscribe. See you in the next video.